Hi everybody, I'm going to make a video for you about CAT scanning. So I'm going to start off the video by talking about why we need CAT scanning and most of all why X-rays on their own are somewhat limited. So as you can see, I hope if I've got everything in the right place, there is a shadow of me on the screen. I'm going to show you why X-rays are shadow images and why we need CAT scanners to find out just a little bit more. So CAT scanning stands for computerized axial tomography. So the axial part means turning, so I'll explain that turning part as we go through the video. And the tomography part means slicing, really. So when you have something that is a has an image that's been made through tomography, then it's made of slices, and so we will see what the point is of that. So first of all, let me show you the limitations of these shadow images. Okay, so I've got a few objects here that I'm taking some video of, and on the right hand side there you see we've got a measuring cylinder. I've got a little burner down here, look. I've got rather a large lime water container. It's a little dirty. But is transparent, and so I've got some kind of reagents down there, a conical flask and a spherical flask there, and also a gas jar. So I've deliberately chosen mostly transparent objects to show you the limitations of X-rays. So in a moment I'm going to rearrange these objects across the room. Now these are all objects that you're quite familiar with, and it is true to say that a doctor, for example, will be very familiar with what ought to be on the insides of a person, but we're just going to use these objects, and you can see their relative sizes there, that the lime water is quite large compared. The tallest thing here, of course, is the retort stand, and some of them are smaller. So let us rearrange them and take another image of them now. I've now rearranged those items through the room. The focusing may not be perfect, but you get the idea. So first of all, I can see nearly all of the objects all at once here. The conical flask now appears to be far bigger than the lime water flask, and we know that's not the truth. And in fact, even the burner is almost half the size. I'm struggling a little bit to see the measuring cylinder. It's back there somewhere though. But the point is, I can see through these items to the next ones to see the ones that are behind, but they're all in a stack in 3 dimensions. So I don't necessarily know the size of them really, unless I have that information. So a shadow image is a little bit like this, except for it's a little better than shadow because you can see things that are behind, as long as the things at the front are not too dense. And with that in mind, let me do another quick rearrangement. So I've rearranged the items again, and this time I put the lime water at the front, and the lime water container is rather dense. You might consider it something that's absorbing a lot of X-rays, and that doesn't mean to say there's nothing behind it. So if I move around, you can see that the conical flask was there all the time, but if I'm using a shadow image like that, I obviously cannot see it, because perhaps the lime water is like bone and doesn't allow me to see those things. So I would much rather see from other angles like this. Now I can see the others, and I can see at the back there even the measuring cylinder. So using a method like computerized axial tomography allows me to see everything where it is from all angles. It in fact creates a 3D image. So I'm going to try and explain how that is to you in a moment. So here I have an object. I'm going to show you how in slices I can find out exactly what it is. So each square there represents what we call a voxel, which is just like one piece of, or like a one 3-dimensional kind of unit, like a bit like a pixel of whatever that object is. Now if I look at this as a shadow image, you can see it's a 4x4 set of voxels, but if I come around now to the back, you can see that that is a three-dimensional image, in fact, and that there are sort of different amounts of voxels making up the shape. So you might consider it almost like a hand, like this. If I see a hand like this and I go like that, it's thicker at the back than it is from face on. So I'm going to sort of explain how this works. So if you can imagine, each of these are a slice. So I've got 1, 2, 3, 4 slices of voxels there to make up my three-dimensional image. And instead of me x-raying from this direction, a CAT scan is actually more like an x-ray going through the other direction in very thin slices, which is like that. So in other words, I x-ray this slice and this slice and this slice and this slice, and then the computer puts them all together to find out the full three-dimensional shape, and then it's created on the computer so that you can move around it and find out what it is exactly. And it's not just about shape, it's also about densities and things like that, and absorption, just the way that it always was before. So to kind of model that a little bit more, I'm going to make up another set of voxels now. So I want you to imagine now that we are looking at thumb end on. So you may have noticed some of the X-ray production questions, I think it's the production ones, you've got things where X-rays have to pass from flesh into bone and then out of flesh again. So here is something a little bit like that, but I want you to realise now that this is actually something that is broken down into slices. Now I'm considering this like one slice of the thumb. So if we went like from that end through, maybe it's easier from this side actually, like that, there would be another layer and another layer and another layer, and the whole thing makes up the thumb. And from the end there, I can't see that there's bone in the middle. But if I were to x-ray through there, if I were to come through this section here, all of that is flesh. And so I would expect less to be absorbed through this end, okay? Whereas the next layer, or the next line of voxels here, pass from flesh into bone and then out of flesh again. And if I went even further up, I put like a different material here. Maybe that's an especially dense area of bone. So if I'm just going to give it like a number for the sake of it. If there were a value of, let's say, a power of 10, I'm not going to say what units of it or anything there are, of intensity of X-rays, you know, so joules per meter squared or whatever, then I would expect more joules per meter squared to come out of this one here than here, because the flesh is not as absorbent as the bone is. And this layer here is going to be even less, because this one here perhaps is extra absorbent, that's made out of a different material. So that's the general idea. And using those values, I can deduce what it is, but I have to do it by x-raying from several angles. So if I want to know what this voxel is made out of, I have to x-ray through that voxel, and when it comes through, it will actually go through those as well, won't it, to find out that value. So to deduce what it is, and I'm just going to take some layers away now, so we can imagine just a bit more simple. If I want to deduce what this one is, I actually have to go through from several angles. So I go through there first of all, and that will give me a value. And then I can come through in this direction as well, and that going through there and there will give me a value. And then I can go through here, and I can get a value, and then come through from this direction as well. And all of those things together will help me find out how absorbent that is. And it will eventually give me, through numbers, a value of the absorbency of what that is, and it would translate that onto the image as a more or less dense thing. So this one is going to show up more dense than that one from this deduction. Now, if you're not following that quite yet, I think it's probably a lot easier to follow when we go through the worksheet that I've designed to help you understand this, and then I can show an exam question and show you what that really means. Okay, so we're going to go through that idea. So the axial part is I'm going to x-ray from this direction, then I'm going to x-ray from this direction, then I'm going to x-ray from that direction, then I'm going to x-ray from that direction. I don't need to go from this direction here at all. So we're going this direction, that direction, and then that direction, but not this direction, because I've already got it from that direction. I don't need to do it again. And equally, I don't need to do it from underneath either, because I've already got that direction from the other way. So if I've gone that way, I don't need to come from underneath, because the reading will be the same. It's passing through the same stuff. So let me demonstrate that with this worksheet. Now, with the worksheet, we're going to work our way backwards from knowing the answers of all of these blocks, and then we can see how the rules make up, finding out and deducing what each and every part of this looks like, and then the slices are built up. Okay, now what you actually have to be able to do in the exam papers is probably easier than I'm making it sound. When you see what you have to do, it's quite simple. And in fact, what I'm going to take you through is even that is more complex than what you will have to do. I'm showing you why it works, and then I'm just going to tell you what to do when you see the exam question. Okay?